So there are a few things I want to demonstrate with what we call a tensegrity model. A tensegrity model is made up, as we can see, out of solid sticks and elastic bands. And they're woven together so that all of the sticks and all of the elastics communicate. And we can see that if I press anywhere or pull anywhere, the whole structure changes shape, whether I'm pulling or pushing. The whole structure adapts to the external force. And this is a property true to the physical body as well, the human body. If I receive an external force, all of the structure will shape change in order to adapt to that force and to that tension. So a tensegrity structure is called a tensegrity structure because tension plus integrity makes that tensegrity has equal distribution of the tension throughout the structure. Another thing I want to highlight is that if we can look close up, none of the sticks actually touch each other. So if we think about it, the sticks could represent the bones and the elastics can represent the ligaments and the tendons, which hold the bones together. So if we know that in the human body, one bone will never touch or never want to touch its neighboring bone, it's to allow the space for this adaptive mechanism. If, for example, I hold the bones together and I try to do the same thing, then we can notice that the structure no longer responds as a whole. See, like that. So then just by one compression, where the bone meets the other bone, the entire structure will be compromised. So what we're looking for always in the human body is that there's space between each of the bones and that the movement be allowed to adapt thanks to the elasticity and the adaptability of the ligaments and tendons, which of course are connective tissue, and that's the subject of today's class.